Hi everyone. Today we're going to study inverse Laplace transform of some standard functions. What is this inverse Laplace transform? Given the function f of t, we learned that the Laplace transform denoted by L of f of t is equal to a function f with respect to s. Then the inverse Laplace transform of f of s is denoted by Laplace inverse of the function f of s. Then we will return to the function of t. Let us see inverse Laplace transform of some standard functions. First, the function 1 over s. Laplace inverse is equal to 1. The function 1 over s raised to n plus 1, the Laplace inverse is t raised to n all over n factorial. Next, the function 1 over s plus a, the Laplace inverse is e raised to negative of the product at. Then the function 1 over s squared plus a squared. Laplace inverse is sine at all over a. Then the function s over s squared plus a squared. Laplace inverse is cosine at. We have the function 1 over s squared minus a squared. We have this Laplace inverse sine h of at all over a. Then the function s all over s squared minus a squared. Laplace inverse is cosine h of at. Let us see this example. Find the inverse Laplace transform of the following functions. Let's begin with number 1. The function is 2 over s. We can show the notation as Laplace inverse of this function 2 over s. First thing we do, we can pull this numerator as constant outside, as it is here. So we have now 2 times Laplace inverse of 1 over s. Then for our formula a while ago, we're going to use the first formula. That is for the 1 over s, which is equal to 1. Let us substitute the value here. So we have now the constant 2 times 1. Then we have 2. This is our f of t. This is our answer. Let us put this answer opposite problem number 1. Then we go to problem number 2. 1 over s raised to 5. The notation is Laplace inverse of the function 1 over s raised to 5. Then look at our list of formula. We have this 1 over s raised to n plus 1. This is the equivalent value for Laplace inverse. In our function here, we can show that this is 1 all over s raised to 4 plus 1, just to define the value of n, which is 4. Using our formula, we have now this t raised to 4 all over 4 factorial. Let us simplify the 4 factorial. We have now 4 times 3 times 2 times 1. The final product is 24. This is our f of t. This is the answer. Let us copy this answer opposite problem number 2. Then we go to problem number 3. 3 over s squared plus 4. In our notation, then we go to our formula. Here it is. That is of the form 1 over s squared plus a squared. In our function here, this number 4, we can write as 2 squared, so that we can define the value of a, which is 2. Then we use our formula. We have now this 3 times the sine of 2t all over 2. We simply combine this constant with the numerator. So we have now 3 times sine of 2t, then we have the denominator 2. This is our function f of t. This is our answer. We just copy this opposite problem number 3. Then problem number 4. 5 over s squared minus 49. We write our notation as Laplace inverse of the function 5 over s squared minus 49. This numerator 5, we can pull it out as a constant. So we have 5 times Laplace inverse of 1 over s squared minus 49. In our list of formula, we're going to use this. This is of this form, 1 over s squared minus a squared. In our function here, we can rewrite this 49 as 7 squared, so that we can define the value of a, which is 7. Now let us use the formula. We have now this 5 times sine h of 7t all over 7. Then we combine this 5 with the numerator. So final answer, 5 times sine h of 7t all over 7. This is our f of t. This is our answer. Let us copy our answer opposite problem number 4. Then we go to problem number 5. We write our Laplace inverse as s minus 1 all over s squared plus 9. First thing to do here is to distribute the denominator to each term of our numerator. So we have now this s over s squared plus 9 minus 1 over s squared plus 9. Then we will show that we are going to take the Laplace inverse of each of the fraction. It becomes like this. Then let us look to our list of formula. In the first fraction here, it corresponds to this formula. That is the s over s squared plus a squared. For this second Laplace inverse, it falls under this category. That is 1 over s squared plus a squared. Looking at our problem now, this value 9, we can rewrite this as 3 squared respectively, so that we can define the value of a respectively. Then we substitute the corresponding values. For the first Laplace inverse, it will be cosine 3t minus, for the second Laplace inverse, it becomes sine 3t all over 3. This is our f of t, and this is now the final answer. Let us copy this answer opposite problem number 5. I hope you learned something from this video. See you again next time.